بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. We'd like to welcome everybody for attending this workshop, which is about energy efficiency. The workshop is organized by the Center of Excellence in Energy Efficiency at KFUPM with an objective to deliver some knowledge to KFUPM faculty, researchers, either from, of course, inside KFUPM or outside KFUPM. So this workshop will be presented mainly by Dr. Azzuddin, Dr. Binash, and Engineer Jamilu. They have long experience in conducting practical projects. So there will be some sense related and some, let me say, example related to the real practice. So hopefully this will be reflected positively to the audience who are attending. You are most welcome for this workshop. Also, I would like to thank Brother Abdurrahman Zahir and Mr. Sanaullah and I think Ms. Imelda from KICS, which is KFUPM Knowledge Institute, for helping us to organize this event. I would like to just introduce about the importance of energy efficiency in Saudi Arabia, why it is important. Before we even we talk about renewable energy, we should think about energy efficiency. Before you think about implementing solar panels on a building, you have to think in advance about energy efficiency, because usually there is more potential. If you want to have the right design for the solar panel, you should design it based on the potential best energy conservation for the building. So why it is important? I'll provide some highlight here. As you can see it, there are different stakeholders for energy efficiency in Saudi Arabia. For example, contractor and supplier. Top management always they concern about energy efficiency because it means saving of money. Investors, it is very important to them. Government, either regulator and standard authority. Beneficiary, anybody who's going to get benefit and use whatever the outlet for that or the outcomes for energy, as well some peers like faculty and engineers. So what is the story of energy efficiency in Saudi Arabia? Indeed, the energy efficiency story started by His Royal Highness Prince Abdulaziz bin Salman, who is taking the lead for energy efficiency in Saudi Arabia. So long time back, the effort started with different program until we have independent or semi-independent center. They call it Saudi Energy Efficiency Center, KFUPM, CEEE. They have excellent number of initiatives, more than 35 initiatives, with a major objective is to reduce the energy consumption in Saudi Arabia 20%, or you can say it in numbers, to save 1 million barrels of oil per day. So what does it mean energy efficiency? It is really a lot. Of course, when you think about Vision 2030, a lot of, let me say, initiatives are based on that. So you can go down and read the vision, you will see a lot of initiative relevant to that, because it is meaning also money and meaning a lot of things. What does it mean here? It means better life, better environment, socially, economically, and so on. So Saudi Arabia launched 30 vision realization programs, and some of them is relevant to energy efficiency directly or indirectly, like the Public Investment Fund. They have their own company relevant, more than one company relevant to energy efficiency. NIDLIB also, they have some initiative related to energy efficiency. Quality of life program, it is relevant to energy efficiency. Housing program, and as well good number of national companies promotion program like Aramco, SABIC, and many others. So it is when you think about energy efficiency, it is not just related to your house, to your use. You can go up to aerospace and defense, automotive, transportation in general, construction, real estate, utility and renewable energy, metal and mining, and telecom, media and technology. So it is overall covering a lot of sectors. So when you thought for the logistic program again, which is NIDLib program, which is major program in Saudi Vision, it has 4 programs. One of them is directly to energy. And by the way, we got big project now in KFUPM here, relevant to energy. We call it Renewable Energy Technical Incubator, where if a student or faculty in KFUPM or even outside KFUPM, he has innovative idea, he can participate with his idea. So there are, in general, this real situation, there are a lot of challenges. For example, insufficient power consumption, supply side inefficiency, and many other challenges. On the other side, you need to resolve and overcome these challenges. For example, current effort increase the efficiency of energy demand. Where there is energy demand, you need more efficient system, or as well when there is, for example, energy production. So for that reason, we need, in addition, develop the right framework for utilization of renewable energy and as well other power technologies. For example, the Quality Life program, which was, I think, announced maybe almost 1 year program and 1 year ago, and so how to have better life among different challenges that you have. As you can see here, for a better design, which is more efficient, and the point here is not just to have efficient, let me say, energy consumption and building. You have to think about the social aspect, the feeling, the productivity, even for the individual who is visiting or living in building X and Y. There are some criteria in the architecture. All these could be considered for the design. As you're aware, His Royal Highness announced, for example, the Green Riyadh, as you can see in the picture, and this is part of the program. Riyadh will move to very, very ambitious program to be more green. There is already a lot of program like King Salman Garden and so on. But the point here is to improve the life quality. What is also more relevant, one of the main initiatives in the kingdom, which each one of us should be aware of, is Tarsheed program. Tarsheed is a big government or semi-government company owned by PIF, and their objective to improve the energy efficiency for government building, and recently they are going toward private sector. And there is business model for where they can generate money and save money, and from the saving difference they can generate money for the new initiative and the new program. So this is one of the main initiative. For example, their mandate to have, for example, 2 million street lights, more than 100,000 government buildings, the schools in Saudi Arabia, the mosques, and the hospital and clinics. So there are really a big initiative. It is really huge and big initiative. And they are doing this one for the government sector for free, but they have their own business model to generate money out of that. So these are some examples of their saving. I will not go through these details, but I want to just let you know about the importance of the topic. When you talk about, this is one of the initiatives by SEEK, Saudi Energy Efficiency Center, in coordination with SASO and different entity in Saudi Arabia. You are aware of this one. This is just one example to encourage people toward using more efficient appliances. Also, this is another example for the cars. And as well, you might hear about it a few months back in the last summer, the government introduced what is called the Mustadam program. Then it was followed up by Saudi Building Code. So all the new building, it should go within specific standards. So this continuously, as I am presenting here, I'm showing the importance of the topic. So I would encourage everybody here to continue the workshop and to accomplish and completed the workshop and its requirements. So one of the things also which is implemented now, we have around 10 million, all the houses in Saudi Arabia will have now smart meter. This is smart meter. It can collect all the detail about your consumptions, and based on that, it can recommend for you a mechanism to save some energy. So this is also, there are Aramco is working on that one. It is not just lighting, it could be for the power plant, for the compressed air, and there are also other benefit, and it is not just energy, because if you reduce the energy consumption, you are reducing also the emission from, for example, the power plant or refinery and so on. So as I mentioned, there is also code, what is called the Saudi Building Code. So they consider there is one specific code for energy, there is another specific code for green building, and there is also another code for light. So it is becoming more important. The government is taking it more serious. Also, if you think about the giga project in Saudi Arabia, we have few giga projects in Saudi Arabia. One of them is NEOM, which is planned to have investment of $500 billion, which is a huge city, really big city, which with 26,000 square meters. And this city will take the state-of-the-art technology, and it will operate completely by clean energy, which means renewable energy, hydrogen, and so on, blue hydrogen or green hydrogen, and so on. So this is the line, which is one of the city. You are aware of it. It was announced by His Royal Highness Prince Mohammed bin Salman. So there is here in KFUPM, you are aware of the business park. And in this business park, one of the major hotel there, it will be green certified hotel. So this is just an example of why the importance or the action which is taken by KFUPM. So in the center, we have a good number of research, either related to renewable energy. I would like to let you know what we are doing, or energy efficiency, or in addition, utilization of Industrial Revolution 4.0 on the energy sector. So with this one, I would like to conclude. I don't want to bother you with these details, but I would like to conclude with this introduction, and to give you the bigger picture about energy efficiency. And it is really important because when you talk about energy efficiency, you can think about almost each sector, because each sector is consuming energy efficiency. So its application is always wide and important, and it has some economic, social, and environmental impact. So by the way, the word sustainability is becoming more, let me say, hot topic, more attractive topic, more important topics, because it has huge impact. And sustainability, when people, they talk about sustainability, they mean, again, energy, environment, and social aspect. Thank you. This is just short introduction about the importance of renewable of energy efficiency, and it's relevant to Saudi Vision 2030, and it's relevant to all the mega and giga initiative by the government. Thank you a lot. If there is a question, short question, we can answer it. I think one of the question is asking about green building. Green building, it has more than one meaning. When you talk about green building, it means from one of the technical definition, it means from the beginning, let me say from the manufacturing of it is a process. First, it is a process. It is not just a process. What does it mean? From the beginning, manufacturing of the raw material of the buildings until its, let me say, construction phase for the building. It consider different criteria where it should meet it such that it will be friendly to the environment, and as well it has some energy saving criteria. So it is a process. It is a full process in general. طيب. One of your colleagues, I think Saif, he mentioned for the standard, I'm not sure, but you might mean if it is building center, if it is very building code, it is already enforced by when you want to have new building, residential and commercial. So it is already enforced. But we have our own code. We have our own code. You can buy it from SASO, and it is also available in the architecture offices in Saudi Arabia. طيب. I think from my side, I'm done. I will leave the floor to my colleague, I think Dr. Binash will start. Go ahead.
Thank you very much, Dr. Fahad. So let me share my screen. My screen is visible to all.
Yeah, great, Dr. Binash, you can start.
Thank you very much. So, Assalamu alaikum wa rahmatullah, everyone. Welcome for this energy efficiency workshop. So today I'm going to discuss about the energy efficiency and conservation and its importance and some informative data I will share with you. So the outline of my presentation will be what is the world energy consumption scenario and how it is going to be in the future. Like, why do we need energy efficiency? And we will correlate why it is very important. Energy efficiency aspect is very important in the Kingdom of Saudi Arabia. Then we will look into the aspects of indoor environment comfort. And then we will talk about some energy efficiency metrics and tools and some energy efficiency initiatives taken by Saudi Arabia. So first of all, if we will look at this world energy consumption chart, as we can see, like the energy consumption has been exponentially in increase, and we can see like the traditional coal, oil, and gas is still basically sharing most of the energy consumption sector right now. So and this is on the right side, you can see like the total annual change in the primary energy consumption, which is around converts to around 2% for the world. But thing is, still we have non-fossil, non-renewable resources constitutes the major share of the total energy consumption around in the global. So this figure on the left side, it shows the total energy consumption by the country, and we can see like the Saudi Arabia, United States of America and China are the primary consumption of energy, followed by developing nations like India and Russia and Saudi Arabia, Brazil. These are also not far behind. But in terms of per capita energy consumption in United States, Canada, in the North European countries, and Saudi Arabia are particularly enormously high. So this means like this country need to focus more on the energy consumptions and energy efficiency sector. So let's have a look at energy per capita energy consumption in Saudi Arabia. As compared to world, the total energy consumption in 2019 was 89 kilowatt hour by Saudi Arabia, and 21,000 kilowatt hour is the mean by the world. Similarly, for electricity consumption, Saudi Arabia is much higher than the world average energy consumption per capita. Energy consumption data as shown in 2020 by the source, it can be seen like in Saudi Arabia, the major share of electricity of total energy is coming either from oil, coal, or gas. In solar, still constituting only very little amount as compared to the other sources of energy. So if we will see like year-to-year change, we can see in 2019, 300 terawatt hour of energy consumption was contributed by solar energy, which means we are going towards a good path because of the major initiatives taken by Saudi government towards the renewable energy. But however, if we will look at the total share, it's still very enormously low as compared to the world. Now, in this slide, I will just discuss about the low emission scenario. So what would happen if the world will adopt the energy efficiency policy and renewable energy policies and effectively apply? So how much energy can be basically conserved and saved? So it can be seen like in 2010, oil and coal and gas, these can be these are sharing more than 80% of the total energy demand. However, with the efficient energy policy and scenario, we can reduce oil and gas contribution to very little, and around 50% can be obtained from the renewable energy resources with proper policies and awareness. Global energy related to CO2 emission by sector, like we can see that the highest sector is power sector, which is consuming most of the energy, and building and industry are the next two, and the transport is also sharing a lot of energy in this sector. So now, why energy efficiency? So energy efficiency is the first fuel of a sustainable global energy system. So if we will look, what is the difference between energy conservation and energy efficiency? Energy conservation is just the practice of reducing energy consumption. So for example, if you are saving water or recycling a product, that is energy conservation, because you are saving energy by reducing the amount of the product. If you are just switching off the light, that is energy efficiency. That is energy conservation. But if you are replacing the light with LED, that is energy efficiency. If you are using a hybrid car, that is an improvement in energy, and that is energy efficiency. So similarly, in you are using a building management system or efficient technologies, which are significantly technologically advanced to use less energy to provide the same task, then this is called energy efficiency. Now, why energy efficiency is the backbone of renewable energy? Because renewable energy resources still needs a lot of production. For example, if in producing the solar PV, or you need a lot of raw material, you need a lot of water. If for producing lithium-ion battery, you need mining, and so many resources is going to be involved just for the production. So until unless you are conserving energy at the same time you are increasing the efficiency of the system, you are not going to do much benefits in terms of the conventional energy with the renewable energy, because at the end you are utilizing the resources and you are wasting the resources, and which is basically harming the environment. So why do we need energy efficiency? First of all, it saves the electricity bill. It eliminates energy waste and energy costs. It also helps in combating the climate change. It reduces the greenhouse gases and other pollutants. As also, as I mentioned, like when you are using more efficient techniques, you are basically reducing the energy production from the first user. So that means the total production of the electricity will go down, and when the total overall production of the energy will go down, that means it's basically helping the environment to towards more sustainability. Moreover, it also helps save individuals money with the amount of energy it is saving. It creates jobs and also stabilizes electricity prices in totality. Some of the benefits of the energy efficiency, as it was reported by IEA.org, if the energy policy would have been implemented efficiently, 2.2 million barrels of oil would have been saved per day only in 2018. 16% of industry electricity usage could be reduced, and it would have saved around $20 billion of the dollars, which is an enormous amount. So this data shows you like total job creation in United States by different sectors. So in 2022, you can see energy efficiency is creating a high amount of jobs. So there is a big job market for energy efficiency, much more than renewable energy itself. And it makes sense because unless you have efficient system, renewable energy is not going to help a lot in towards the sustainable development. Now let's focus on the scenario of Saudi Arabia. So this this chart shows you the energy consumption by different sectors. For example, residential, government, agriculture, industrial, and different sectors. We find that most of the energy consumption, around 50% of the total, is basically taken by the residential sector. And this is due to the fact because of the environmental condition of Saudi Arabia, which requires a lot of cooling, as can be seen in the this graph, this chart. Around in different cities, the majority of the electricity inside a building is utilized by just the cooling system. And the next biggest consumption is lighting inside a building. So energy efficiency scenario, what this graph shows you, like how much energy could have been saved if we would have implemented efficient world scenario, where all the new policies and sustainable policies would have been implemented efficiently. So we can see, like if this is the current scenario, if this is how the energy is like a new policy scenario, where the energy implementation is just as it is going right now, but it's efficient world scenario. So we can see there's a humongous amount of opportunity to save energy in the building, in the transport and industry as well. This graph on the right, it shows you the energy efficiency ratio, signal energy efficiency ratio in for air conditioning available in the markets in different regions. For example, Europe, China, United States, India, and Saudi Arabia. And this is the market average of what people are buying. So we can see there are high energy efficient or high energy efficiency rating air conditioning systems are available in most of the market, especially in Saudi Arabia, in United States, and in Europe. but still the market average of all the energy of the air condition is still much lower than the available in the market. This can be because of the low energy cost, especially in Saudi Arabia, and low awareness among the people and the citizens who are not very much aware about the energy efficiency and the sustainability problem. So if we look at the world scenario, what is possible by 2020? As reported by IEA, and total space building could have been saved, could be increased to 60% without additional energy if efficient policies would have been implemented with energy efficiency. And also 60% of the savings could be achieved from the space heating and cooling and water saving, which is basically highly, as shown in this figure, which constitutes the most part of the energy consumption inside the Kingdom of Saudi Arabia. So that's why it's even more important in this case of Saudi Arabia. Now, what are the key policy actions? So basically, comprehensive and efficiency regulation targeting both new and existing buildings should be applied. This could be one of the best policy, and these are being implemented in Saudi Arabia. However, higher incentives should be adopted and encouraged inside the kingdom, and high efficiency appliances should be more implemented. Also, the data and information about the availability of energy performance should be more available, should be made more available to the people, so that they can basically be more aware and reduce the energy consumption in the kingdom. So now we will focus on the building design. So as the Saudi Arabia, building is the most energy consuming sector, we will focus mostly on building design in this presentation. So more important factors are insulation, air tightness, ventilation, equipment, and then finally at the end, renewable energy. Now, if these are implemented, this can basically reduce the total heat loss. It will increase the comfort inside the building, the quality of the air, moisture management. It will optimize the regulation and control, and it can basically be adapted to depending upon the temperature and the humidity of the system. So some related action that can be taken is like the orientation of the building and the shape of the building, shadings and the wind plantation around the buildings, then insulation, floors of the floor, walls, roofs, and the ventilation of the building should be taken care of, like the air tightness among the roof, in the windows and the frame. Then higher energy efficiency, air conditioner, boiler, heat pump, and these other equipment can be employed. And then finally, renewable source of energy should be made more available. Now, what is indoor environmental quality? Since more than 90% of our life, as suggested by one of the studies, suggests that we remain most inside the building. So it is a very important fact. Like, we need to be comfortably from holistic approach, so that we will be more efficient in inside the indoor environment. So indoor environment refers to the quality of building's environment in relation to health and well-being of the occupant. There are basically 4 major sectors for energy for the indoor environmental quality. Those are thermal comfort, visual comfort, indoor air quality comfort, and acoustic comfort. So we will go one by one through all of them, just to have a brief idea. So visual comfort is basically proper lighting system, which will little strain in our eyes, and which will allow us to work comfortably for longer period of time. So factors are like the components which we are working on, and the light intensity, how much is the light intensity in the environment, what is the color temperature of the light. So for example, it depends. Sometimes you basically feel very bored. For example, if you have too much yellow light in your work environment, you will not feel comfortable working in that color. But if you have yellow light in the restaurants, you will feel more relaxed and easy. So color temperature is also a very important factor. Light intensity, as we all know, sometimes a room is less lighted than the required one, and this will cause the strain in your eye and headache. Sometimes it is over over light is there. The intensity is higher than the recommended value, and this also causes some problem. Similarly, we can have a problem of the glare inside a building, like if there is a reflection from a shiny surface, or if there is a window and we are having a bright sunlight falling on our eyes. So all these factors should be considered while we are designing the indoor environment in terms of the light. So various light levels are basically a standard has been set for different areas. For example, you don't need same light value while you are eating in a cafeteria, which is set to be like around 200 or 300 fracs, as much light as you would need inside a conference room. So similarly, you have a different values for the level, standard values for lighting level in a classroom or in a laboratory or in a hospital or in different places. Now, these are the standards of lighting intensity. Now, there is also power density, like how much watts are you spending per amount of light you are getting. How much, for example, how much watt you are spending to get the particular lux of lighting at the energy. So for that also, IECC has set some standard value for power density. So when we are designing a cafeteria, we should take care of like the light intensity should be of this value, and the power density should not exceed this value. Then we will call it like energy efficient lighting system. Now, for acoustic comfort is basically the well-being and feeling of a building or occupant regarding acoustic environment. So if there is a lot of noise from outside or continuous or a high-pitched sound, either it is coming from the AC duct or from the Wi-Fi routers or some server or anything, like these are going to impact our acoustic comfort. So for this also, a standard had been set, and we need to take care of that it doesn't exceed. For example, in complex task equivalent to continuous sound level, it should not, in general tasking level, it should not exceed 55 decibels. However, for offices and for like offices with the very professional level work going on, it should not exceed more than 40 decibel to 45 decibels. There are design factors for acoustic comforts, like what are the depending upon the surroundings and depending upon the type of materials you are using, depending upon what type of offices or other buildings you have in the around, and we need to take care of while we designing a building. Now, indoor air quality comfort. This basically refers to the amount of pollutants that is present inside the indoor environment, and like indoor air or pollution basically can cause different problems like nausea, headaches, sick building syndromes, and lots of other hazardous diseases. So in this table, we can see a group of different pollutants, and their limits are prescribed. So it is very important, like in the kind of environment you are working, you should basically take care of what are the pollutant levels the occupants are facing every day. So and these depending upon the environment condition, like they are either inside the industry or in a commercial building, we have different kind of pollutants, and these need to be monitored, and the proper ventilation system should be there to minimize the effect of pollutant. Now let's come to the thermal comfort. So thermal comfort is described as the state of mind when you feel comfortable with the environment. So it can be a thermal comfort can be if you have a very dry air, you can feel drought, which is thermally uncomfortable. If you have radiation asymmetry, one side is very hot, like if you are sitting near a boiler in a industrial facility. So this will cause you a radiation asymmetry. Or if you have solar radiation falling on the wall, on one side of the wall, you will feel radiation asymmetry. So this will also cause uncomfortability. Then there is vertical air temperature gradient. If you have more than 3-degree temperature gradient from your foot to head, it will cause discomfort for human being. And this is also while designing an indoor environment, we take care about the uniformity of temperature inside the building. And moreover, the floor temperature is also not negligible. It is another factor. So what are the factors for thermal comfort? Basically, there are 4 environmental factors and 2 personal factors. 2 personal factors are clothing and metabolic rate, like what type of clothing you are wearing inside a building or a house, and what kind of activity you are doing inside a building. This will constitute to the metabolic rate, and these are the personal factors that affects the thermal comfort. Then there are environmental factors like humidity, air speed, air temperature, and radiant temperature. So we basically need to take care of all these factors while we design a building. And I will discuss with some example in the next slide. So when do we say like we are thermally comfortable? Like thermal comfort is basically relative. Some people might feel comfortable at particular temperature, but other people may, other person, he may say like he's not comfortable with the temperature and the kind of environment. So to basically design the thermally comfortable environment, it has been suggested by the IRC standard that if more than 80% of the equipment expresses their satisfaction, then the environment will be called thermally comfortable. So, but the problem is, how can we know like more than 80% are comfortable? Making a real survey is a really difficult task. So there are mathematical models which can predict the comfortability using predictive mean vote, like how much with different factors. For example, if you will put the input, like what is the metabolic rate and the clothing condition, air temperature, and all the factors, if you give an input to that mathematical code, it will give you a PMV value, which ranges from -3 to +3. So this is the chart which shows like if it is coming to be 0, that means it is almost neutral, and most of the people, around more than 95% of people, will be satisfied. Now, there is a correlation between predictive mean vote and people of person dissatisfied. This graph basically correlates this value. So for example, if your PMV scale comes between 1 and 2, around 1.5, you can check like it is from 1.7 here. So this is, if you will go, like you can see, like around 70% of people are dissatisfied at this level. So this is basically in the region of slightly warm to warm region, and most of the people will be dissatisfied in this region. I will give you one example of how this thermally comfortability basically depends upon the kind of different factors. So here, metabolic rates are defined as one unit is equal to 60 watt per meter square. And for different activities, it has different values. So for example, for sitting, you have one metabolic unit. For cleaning, you have 3. And for running, you have 8. So depending upon the kind of activity, you can input these values into the mathematical model and other factors to guess the assume the what is the comfortable temperature where most of the people will be satisfied. This first example is about a butcher who is having a very heavy clothing, which is 1.7, and his activity level is high, around 2.5. Relative humidity is kept constant at 50%. So for him, the comfortable temperature will only be 6 degrees Celsius. While if a person working in office, if the temperature is 6 degrees Celsius, he will be freezing. If a mechanic with almost same activity range and 50% of humidity, and the clothing level is decreased to 0.8, which is lighter than the butcher, the comfortable temperature will increase to 18 degrees Celsius. While a person working in office with low clothing level and just a small activity level with same relative humidity, you have a comfortable temperature of 24.5 degrees Celsius. Depending on the kind of clothing, type of activities people are doing, indoor environment should be designed based on all these factors. And there is not just a simple one universal temperature or thermal compatibility parameter. This graph basically shows you the effect of air speed on the comfortable region. So obviously we can see this is the green region is showing the comfortable zone with operative temperature from 23 degrees Celsius to 27 degrees Celsius based on different type of air speed. And while others are either too hot or too cold, and this is showing you the too drafty, very high wind velocity. So various factors needs to be taken into account while designing the indoor environment, ranging from the insulation, from the orientation, the material we are using, the kind of ventilation and air recirculation inside the system. So basically all these the air temperature and these other factors like orientation and the thermal inertia, the type of material we are using depends upon this can only be implemented at the time of designing a new building. However, when we try to make the old building more comfortable, we need to middle up with the HVAC system, which basically controls the temperature, the air velocity, as well as the humidity inside the environment. So we will not go deep into the HVAC system, but just a brief introduction. Like there are two main kinds of air conditioning system. One is non-ducted and then the ducted type. So in non-ducted type, we have a split type or window type AC system, which is most common in the residential buildings. Ducted types are like package type or centralized type, which is more common in the commercial buildings. So this is a design of the HVAC system. This is a window AC system, and there is no provision for fresh air inside either a window AC or a split AC. In both of the systems, in a split and window AC, the same air is being recirculated using this fan, and it is being cooled. So there is no basically in non-ducted system, we don't have any ventilation for the HVAC system. However, in the ducted system, we have provision for fresh air recirculation. So we can add some fresh air, and we can also recirculate depending upon how much recirculation is required. So we can the amount of recirculation again depends upon the type of building and how many people are inside the building, what is the concentration of carbon dioxide and other pollutants inside the building. So this will determine how much fresh air should be recirculated. And we do not want to recirculate all the fresh air because it is going to cost us a lot of energy. So an optimization between the fresh air is the best option. This is basically a typical schematic diagram of a HVAC system. So this is a ventilated room where cool air is coming in, it gets heated, and we have a suction which is recirculating this air, and some part of outside air is being mixed, filtered, and then thrown to the coil, and again recirculated into the ventilation system. Now, depending upon either it is for the heating or it is cooling, we have boiler or a chiller or a cooling tower, which is providing the energy transfer through these coils. Now, without going deeper into the HVAC systems, we just want to get an overview about the energy performance. So energy performance of an air conditioning system can be evaluated using coefficient of performance. So higher, it is basically the ratio of heat absorbed divided by the total power consumed by the HVAC system. So higher the value of COP means higher, the better the efficiency of the system. We know that the split AC and the window ACs, and these have very low COP. So these are less efficient than if you have a chiller, which can be ranging from up to 6.5 the value of COP. So these are the energy rating which you can find when you are going to buy any AC or any electrical equipment, appliances or equipment. Now, why it is very important to save the energy at the end user? Because the amount of energy you are saving at the end user is affecting the producer. For example, in this system, I will show you how it is going to affect. So basically, whenever there is a thermal energy involved, the total efficiency is very low. For example, in this case, you can see this chemical energy is basically converted into internal combustion engine to produce thermal energy, which is only 30% efficient. Then this diesel energy is converting into the mechanical energy, and then this generator is converting mechanical energy into electrical energy, and which is driving the motor to get the mechanical energy, and finally we are getting the pump for pumping the fluid. So the total efficiency of the system from here to the end will be the multiplication of all the efficiency from diesel to generator to motor and pump, and this will be only 12%. So the energy efficiency of each of the component is very, very important, and because any low value in any one of the system will eventually cause to fall the total efficiency of the system tremendously. Now, this is the impact of the energy efficiency on the total efficiency. However, the energy efficiency also has a tremendous impact on the cost of the energy. For example, point of use cost is defined as the cost of energy per common unit divided by efficiency of the conversion. So higher the efficiency of the conversion, higher the point of use of cost you will have. So, for example, if the purchase cost of electricity is $0.2 per kilowatt, and the efficiency of the equipment you have is only 30%, then the actually you are paying this much amount for the per kilowatt hour of the energy usage. So similarly, if you have purchased energy at this much, and this is the plant efficiency, the total energy, this is the total energy wastage. So basically you are effectively, you are using only 30,000 kilowatt, and you are wasting like 70,000 kilowatt if the plant efficiency is only 30%. So you are wasting a lot of money if you're not saving or increasing the energy efficiency of the system. So uh, for making all the standardization, how much efficient should be a building be? Energy use intensity is basically used, where energy use intensity is defined as total amount of energy per unit area of the floor. So for example, in a restaurant, it is showing the site energy efficiency as well as source energy efficiency depending upon the efficiency of the restaurant, as I showed in the slide before. So the site energy efficiency is this much, around 300 uh, kilo British thermal unit divided by per square feet to around 600 for the source EUI. So for different uh, for different building types, the median energy use intensity is described in the United States, is here, like this data you can see. And there are also standard values. What should be the standard values for restaurant? What should be the standard value for supermarket, for hospital? And while conducting an energy auditing, we can assess what is the energy use intensity, and then we can compare it with the standard value and the benchmark, and we can make some improvement depending upon what requirements, what energy efficiency measures it can be applied to improve the energy efficiency of the building. So building performance analysis can be done using energy audits and assessment, which is basically verification, monitoring, and analysis of use of energy. So basically, we put some mechanism to analyze how much energy is being consumed in which sector, in which sections, and how much inefficiently, how much energy we are basically losing in different aspects. And once we have all the data, we try to investigate it through analytics or using some softwares like ESPR or design builders, and we can find out like we can recommend some recommendations how to improve the energy efficiency of those buildings. So this energy audits and assessment will be explained more in detail by the next speaker, Indian Jamilu, inshallah. So now we will discuss some energy behavior change program and education that are important in the kingdom. So setting up energy policy, target, and goals for the organizations are one of the very important energy behavior change program that will help increase the energy efficiency and overall educate staff members on energy efficiency and practice. Like we have to create the awareness through print medias and banners and posters. We can have a walk rounds and listening a staff share suggestions. We can have display of the energy use information in the past 6 months, and like every half yearly, we can report how much energy we are spending and how much we are improving, how much we are saving. So this will give an impetus and boost to save more energy and work in that direction. Hold energy fair and conduct energy awareness events, and appointing energy champions and giving incentives and recognitions. Now, this energy efficiency improvement is one of the very important objective of Saudi Vision 2030, as it was also discussed by Dr. Fahad in the previous presentation. So the Saudi government is very keen in enforcing energy taxes, using energy labeling of appliances, creating publicity and awareness campaigns, then establishing standards for new buildings, providing incentives to support energy efficiency improvements in existing buildings, and also setting grants and loans towards energy saving measures. So this is all from my side for today's presentation. So if anyone has a question, you're most welcome to ask.
Someone raises hand also.
So does anyone has any question?
Yeah, Rashid Al-Marshid.
Okay, Rashid Al-Marshid. Please, you can unmute yourself and speak, or you can type your question.
His question is,
okay. Replacing traditional grid with smart grids along with high % of renewable energy penetration, could it be optimal solution to improve energy? Yes, obviously. Using a smart grids and a smart appliances, IoT, Internet of Things, and better building management systems, these all are included in the Industry 4.0 revolution, and these are very effective solutions for energy improvements. Basically, these can collect lots of data, and there are lots of chances to, with lots of data, you have chances to optimize the energy distribution, and you can minimize the energy wastage through proper management system. And these are one of the basically a very efficient way of saving energy. What about energy blend option in KSA? Right now, as I discussed in my previous slides, now the majority of energy is coming from the conventional source of energy. However, there is energy mix, and there is a great shift towards the renewable energy sector in the recent years. Saudi Arabia has a vision of getting around 50% of renewable energy electricity generation by 2030, and net zero carbon emission, like most of the energy generation will be through renewable energy sector by 2060. So there is a lot of opportunity, like new kinds of energy, like hydrogen and solar and hybrid systems. They are going to evolve in Saudi Arabia in coming days. Does energy recovery ventilation increases the? Okay, it depends upon the building design, and that's why we need. So the question from Asim Maqbool is: does energy recovery ventilation increases the efficiency remarkably? So this is very specific to the type of building you are working on. So depending upon like how much ventilation and how much recirculation is required in that building, and how much is basically being wasted, what is the total pollutant concentration. So we need energy auditing, a complete analysis of the ventilation and HVAC system, and we can see how much energy recovery ventilation could enhance the total energy efficiency of the building. Okay. Some of your information is not applicable to Saudi standards. Okay. Some of the data I have shared is on the global, some of the global data which has been shared to us by IEA and other different organizations. So obviously these are not applicable to Saudi Arabia. However, there are other informations which are relevant to Saudi Arabia context. What are the future jobs associated with energy efficiency? Yeah, as I discussed in one of my slides, let me just go back to that slide again. Yes, this slide, as it can be seen, energy efficiency in 2020 sector in United States, it has seen highest job creation, highest job market in energy efficiency, much more than renewable energy. So this is because of the because as I discussed, like even if you are introducing renewable energy in the production of the resources, like the infrastructure development, you need to develop the infrastructure more efficiently. if you are not developing the infrastructure efficiently, you are violating the cause of sustainable development. Hence, at each and every step of renewable energy, you will need efficient system, management system, and that's why there is a lot of opportunity in the energy efficiency market right now, especially in context of India, as Saudi Arabia has a lot to go towards this energy efficient plan.
Instead of 10 minutes, right?
Okay.
5 minutes.
Sulaiman, should we have an energy consultant for new building to fulfill code requirements? Yes, of course. There are so many energy service providing companies have they have got a new entrepreneurship inside the Kingdom of Saudi Arabia because of this reason, because you need a consultant who will advise you to follow the code and make the new building or existing building more energy efficient. However, due to lack of the proper regulations and implementation inside Saudi Arabia, there is not too much right now there is not too much prospect for that one. However, like within few years, we are expecting it to grow to a very high number, as we have very ambitious plan to go for 50% renewable in by 2030 and net zero by 2060. So later on, now it is going to come. Like we are going to have lots of need for energy consultants, and there are a lot of opportunities in this sector. Hannah Mohammed, what are energy efficiency standard you based on it in the ventilation system? For an ventilation system, there is the American Society for Ventilation, HVAC and Ventilation System. We call it ASHRAE, ASHRAY. So I will type this in my chat.
ASHRAE. Will be in my presentation.
So one. Yeah, I have typed the name of this standard, ASHRAE. This is the energy efficiency standard which deals into the ventilation system, indoor can convert like total heating and cooling load, relative humidity, and ventilation level.
Will be discussed for that.
Abdul Rahman Al-Duhabi, did you compare it with the Saudi building code? I didn't get you. What did I compare with the Saudi building code? So maybe your question could be more explicit for me to answer. In terms of energy use intensity benchmarking, is there any specific tool that can be used that is tailored to Saudi weather condition, like Energy Portfolio Manager in United States? Basically, we can use different softwares, as I discussed in my presentation slide. Let me just go to that slide. We have different software tools like eQuest, ESVR, Design, in which you can input the weather condition, weather data of any city of the Saudi Arabia, and then you can design and model your building according to that particular weather condition. So, okay, if there is no more questions, I will leave my
5 minutes, right?
there will be a 5 minutes break, and then we will be back with another presentation on energy auditing and instrumentation by Engineer Jamilu. Thank you very much.
Okay, Assalamu alaikum wa rahmatullah. Thank you everyone, and welcome back to the last and final session for today. I hope I am audibly clear. Okay, so having gone through the previous two presentations, we have understood the importance of energy efficiency and how it's important, especially in the context of Saudi Arabia. Now we'll focus into a bit more specific aspect of energy efficiency improvement, which is energy auditing and assessment, as it was introduced by the previous presenters. Okay, so our presentation, it's going to highlight more into the introduction of energy auditing and assessment. This should cover the definitions, advantages, steps, stages, and what have you related to energy auditing and assessment. There would be internationally recognized levels of energy auditing. We shall highlight that. We will dwell more into energy auditing and instruments thereafter. As some of you were asking about codes and standards, we will briefly go through the energy audit codes and standard as well, performance rating, and some environmentally sustainable views from religious perspective. Considering the time of the day and the nature of the program, we shall be as brief as possible in order to minimize the time. So what do we mean by the term auditing in general? Auditing means to verify, to monitor, or to do some analysis. So basically energy auditing and assessment, now we need to relate, because we have auditing in different contexts. We have financial auditing. So the word auditing in general means to investigate. So energy auditing, now we relate it to energy utilization in the context of a facility or a building or any space. So the process of conducting this verification or monitoring or analysis with the purpose of submitting a technical report, which should contain some recommendations with the aim of improving the energy efficiency, and it should also have some cost-benefit analysis. So this is all about energy auditing. So the term auditing, as you may come across in different literature, it may be referred to as energy survey, energy investigation, energy analysis, energy evaluation, and different names related to this context. So they all mean the same thing. So in a nutshell, to summarize what energy auditing entails, in energy auditing, you pay attention, or we pay attention to how much energy a facility or a building is using, where it is using this energy, if it's being used efficiently or not, and if we can improve this through conducting energy auditing. Of course, this will come from our recommendations. So there are some basic steps which any energy auditing, irrespective of the level of the energy auditing, it should somehow contain these steps. So we start by analyzing historical energy use, because this will give an idea of how energy is being utilized in such a building or facility. So preferably at least historical energy data of about 2 years is preferred, but nonetheless, if you can get just for a year, it should suffice in some cases. So after analyzing this historical energy usage, we gather data, consider some operational features, indoor air quality and indoor environmental quality of the location where the building or facility is located. We move into identify some potential measures, carry out some analysis, some economic analysis and calculations, which will enable us to understand and come up with some appropriate measures in order to improve this energy, the energy utilization in such space. And at the end, there has to be a report which is well documented and submitted that contains the whole process, which the client can use to improve energy efficiency in his or her facility by implementing some of the recommendations. So these stages that have been, the steps that have been illustrated in the previous slide are just almost the same that are illustrated differently here. So there has to be an agreement to begin any energy auditing, because there has to be a contract between the consultant or the certified energy auditor or energy manager and the client. Then we go into the description where you need to understand this is where you collect the previous historical energy usage, conduct the actual energy auditing, and perform analysis, come up with improvement plans, and have a report at the end. And these processes needs to be repeated over time. So if you conduct energy auditing in a building, after 5 to 10 years, it is understandably there should be some changes, so the efficiency may reduce. So energy auditing should be conducted in order to keep up with the energy efficiency. So what are some of the advantages of conducting energy auditing? To any, why should someone invest his money to conduct energy auditing? So the client needs to be persuaded, the client needs to understand the importance, he needs to look at it from his own perspective. What will be his gain for investing certain amount of money in conducting energy auditing? So some of these importance, advantages, they are like the energy auditing helps in spreading awareness in the context of energy efficiency. You would reduce operation costs, you would protect the environment, you would prolong equipment lifetime, conserve non-renewable energy sources, also to reduce the operation and maintenance costs, among other advantages. So if we understand a building in the context of energy utilization, if we have a building A and certain quantity of energy comes or is supplied to that building, so at the end of the day, the useful energy that is that we get from that is less than the supplied energy. Why? Because there are some losses along the line. So energy auditing allows you and assists you in finding out where are these energy losses taking place. If you are able to locate them, you would be able to devise some means to minimize, if not to eliminate them completely. So this is why energy auditing and assessment is key. So what are some key areas in any energy auditing which needs to be some attention? So while conducting energy auditing, one of the most important aspects is the building envelope, because as we know, in any solving any problem related to building and construction, so the best way to control a problem is don't allow the problem to come into your building. So if you are able to keep the problem away from your building, you would serve a lot. So this comes if you carry out effective building envelope design and construction, as it was highlighted previously. So this is where you need to adhere to the codes and standards. You need to ensure that the U value has been met. You need to ensure that the materials that are utilized are of high U value to be able to minimize this problem. So the heating, ventilation, and air conditioning system, as we've seen, it's an integral aspect, especially in the context of Saudi Arabia. The lighting system, it's often overlooked, but depending on the nature of the facility, sometimes it consumes a great percentage of the total energy consumption. It can range between 3 to 10% of total energy utilization in any building. of course, it depends on the utilization, on the context, on the nature of the facility, what the facility is being utilized for. Then we have the energy consumption in general, especially, for example, in this context, you pay attention to the electrical, to the electricity consumption in that building, and other miscellaneous consumptions or activities that will come from equipment and other processes or activities that take place depending on the nature and usage of that building. So now for us to understand building as an energy system, the interaction, a lot of interaction takes place between a building and its surrounding. There is also other interaction that happens from people and equipment and utilities from within the building. So there is a lot of exchange that takes place, which requires some investigation in order to improve the energy efficiency. So what are the various levels or types, if we may put it this way? There are different levels of energy auditing. So as presented by Dr. Binash previously, according to the American Society of Heating, Refrigerating and Air Conditioning Engineers, we could say there are 3 main levels of energy auditing, but however, we have what we call as benchmarking, which is almost the current level of almost the current level of the building or facility. So we have 3 levels of energy auditing, as we would see in detail as we progress. I would like to highlight here that the complexity of task and demand of the energy auditing increases with the increase in the level of the energy auditing. So what I mean here is that level 1 energy auditing, which is basically a walkthrough analysis or preliminary audit, it would require less work, it will require less analysis, it will require less cost when it comes to, if you compare it with level 2. And if you choose to go for level 2 energy auditing, you cannot jump or skip level 1. So if you are conducting level 2 energy auditing, it means that you are starting from level 1. Indirectly, level 2 will include level 1 plus other aspects. So level 3, if there is need to go for level 3 after level 2, indirectly you would have to, level 3 would include level 1 and as well as level 2 energy auditing. So if we are conducting level 3, we're actually building up from where level 2 stops. So the higher we go, the more complex it becomes. By the way, just for your reference, apart from ASHRAE, which is just one of the standards, there are other standards depending on the country or region, as we have the Federal Building Initiative, the Natural Resources of Canada. So some of the activities that are required when it comes to conducting energy auditing, level 1 energy auditing, it will require to have a brief on-site survey of the building. And if you go to the next step, you will need a detailed on-site survey of that building. So there's need for building energy benchmarking. There has to be the actual energy auditing, which will require some analysis for savings and costs, for no cost and low cost energy efficiency measures. And the energy efficiency measures at times are referred to as energy conservation measures in other literature. So one needs to identify potential means for improving the energy efficiency. And there has to be some incentive programs that are outlined as well. So as we build on from level 1, now it will require a detailed survey analysis of the building, detailed breakdown of energy use and of energy sources and their end use, identification of the energy efficiency measures, and other aspects which are in addition to what has been conducted previously. So in a situation whereby level 2 energy auditing has been conducted and there is need to further investigate certain aspects, usually, for example, in level 3, which is a detailed analysis of capital intensive modification, usually after conducting level 2 energy auditing and then the two parties agree that there are some of the recommendations which will require further investigation in order to adequately comprehend and estimate the savings, and also to get a clear picture of the whole energy efficiency measure. So there could be like a subcontract to continue from level 2 in order to perform level 3 energy auditing. This level 3 would require, as we've seen previously, sometimes there is need for building simulation tools in energy auditing. So building simulation tools are required in level 3 energy auditing. Usually in level 1 and level 2, there may be no need for such simulations. But in order to accurately get the details of some of the recommendations in level 2 energy auditing, there may be need to go to level 3 and use some of these simulation tools. So if we come to energy auditing tools, the instruments that are utilized in order to conduct this energy auditing, we can classify or we can have the different measurements conducted into 3 categories. Some measurements are conducted just on the spot. You go with the instrument, you take the measurement, and immediately you move to another location and continuously repeat the measurement as required. Then there are some temporary measurements that are conducted using data loggers, which you need to install, for example, in the main feed of a building or facility, and leave it for some time, for some hours, for some days, for some months, depending on the requirement of that project. And there are permanent metering also that are integrated with the building. So if we start with the energy auditing instruments, for example, we have what we call the power quality and motor analyzer, which has almost similar function with an e-gauge meter. We have other tools that are required in power related measurements, such as the amp meter, the light level for light measurements, as we can see in the slides to come. So what power and quality and motor analyzer does is that it measures electrical parameters like voltage, current, the basics, and in addition, like power factor, harmonic distortion, and unbalance. So this will enable one to get clear knowledge of the power quality in that location, what's happening. You'll be able to identify if there are some need for attention. So it measures power quality in detail and allows you to make some quick analysis using the user-friendly screen. It also calculates mechanical power and efficiency. So the e-gauge meter, which has almost similar function, but has some flexibility. Yeah. So sometimes depending on how the electrical design, when it comes to the main feed of a building is conducted, the e-gauge meter may come in handy because it's quite flexible. It has about 15 channels, which will allow you to get the overall electrical load of the building, and also segregated load, for example, for lighting, for the pumps, for HVAC. Depending on how the design is, you will be able to, using one e-gauge meter, to connect 15, using the one e-gauge meter to connect 15 channels. So it's very flexible. With the help of CEEs and the current transformers are required in this regard. So the clamp meter allows you to check, especially to understand, because as we see in the previous slide, these current transformers have sizes. So you need to check with the clamp meter to understand, okay, if there is a current flow in that electrical panel, and also to understand the size of the current transformer, which you may need to use in monitoring the power in that building or facility. So it could also be used to identify motors that are oversized or overloaded. So it's also important. This is like an advanced version of a clamp meter. You use it to measure current, voltage, and resistance, and it's also used in diagnosing circuit and testing of a battery and other functions. So the digital lux meter, this is an instrument that is utilized in measuring the quantity of light that is received at task plane in any facility or location. So for example, as we've seen in the previous presentation, that okay, there is a certain quantity of light or light luminance, I would say, that is recommended in different locations based on the function. So this is the instrument that you use to take this measurement and to identify the location that has, okay, whether light is provided efficiently or inefficiently, whether there's enough light. If there's enough light, how is it being provided using the lighting power density? You will be able to see, okay, how much energy is consumed in providing this light, if it has if it is in accordance with the standard, and also you would be able to see, okay, how the light is distributed, because it's very important to distribute light uniformly in any space, especially light, especially where the light is needed. So this is the instrument that is being utilized for such measurement. So as we've seen previously, it's highly important to ensure that the building envelope is designed and constructed according to the requirement of the standard. Thermal imaging camera is used in order to check this during an energy audit. So the thermal camera is used to identify or to check the efficiency of the building envelope. We would see in detail. So it's used for electrical inspections and radiant heat location, be it in cable, in the building envelope, in electrical panel. So it's very important because there is need to identify heat loss. So the building envelope, as we know, that it comprises of the roof, the foundation or the floor, the windows, the doors, the walls. So it's very important to check how airtight is the building envelope from various components of the building envelope. So the thermal camera will allow you to check for temperature ranges between -20 to about 650 degrees Celsius, depending on which type is deployed for such purpose. Thermal other instrument used for to check thermal comfort during an energy audit, data loggers. So we have the temperature and relative humidity data logger. We have the light and occupancy data logger. We have a CO2 sensor also, which in addition to its function also allows you to check the temperature and relative humidity in addition to CO2 levels. We have some web-based data loggers, and for some motors, especially for industrial applications, they are smart sensor to check the efficiency of motors as well. Indoor air quality is an integral aspect of human comfort in a building. So there are some tools which are deployed during an energy audit to check and monitor the quality of indoor air. So for example, the airborne particle counter allows you to monitor fine particulates to determine the concentration in the space and also to access the quality of the indoor air. It detects pollutant of different sources and provide you information on the variation of the pollutant levels. As Dr. Binash presented, we've seen that, okay, for different pollutants, there are certain limit, allowable limit, depending on the building function. So this will allow you to conduct measurement for CO, SO2, NOx, and other inhalable suspended particles ranging from 0.1 micrometer to about 10 micrometer. So the airspeed in a space is an aspect of thermal comfort, and it also needs to be investigated. So for example, thermal anemometer could be deployed to check temperature and velocity and direction of fluid, be it air or liquid in a space, because if the speed is too much, it will affect thermal comfort, and if it's also too low, it will also affect thermal comfort. So it's also important to check all this. And pitot tube also measures the velocity of a fluid, of a flowing fluid. Heated thermocouple could also be used to check the temperature. In industrial settings, we have compressed air gases, which is very expensive. So ultrasonic leak detector allows you to check for leakages in compressed air pipes and connections. So it converts leaks that are generated into audible range in order to be easily detected. It detects the noise that is created for different gases, regardless of the type. So for chlorofluorocarbons, nitrogen, and other gases. We have the gas analyzer for conducting, for analyzing exhaust gases. So it is it has different chambers. It can allow you, for example, at times to use up to 5 or 6 chambers at the same time. So you can select which sensor you want to use at a point, and with the help of a metal probe, you can conduct this measurement in any location of your choice based on the function of the facility. So for rotational speed, we have contact and non-contact. We have contact and non-contact thermometer. Tachometer. However, there is like a hybrid tachometer, which allows you to take simultaneous measurements for either contact or non-contact at the same time. Building performance simulation has been already highlighted previously. So this comes into play when there is need to go for level 3 energy auditing. However, if we are just limiting ourselves to level 1 or level 2 energy auditing, we may not need to deploy building performance simulation tools. So coming to codes and standards, there are different codes and standards from different societies or entities. Also for so depending on what you are looking for while conducting energy auditing, you need to be able to identify the appropriate code which you need to make some comparison. So for example, the ISO 50001 is a standard for energy management, and it's like a combination of the previous ISO 90001 and 14001. If you need standard for buildings that are high rise, except low rise residential buildings, for any building except this category, you need to check ASHRAE 90.1, and ASHRAE 90.2 is for minimum energy efficiency requirement for low rise residential buildings. So we have different standards, as we can see. There was a question earlier. So this will give you an idea of the various standards available out there, be it for hot environment, for predicting sweat rate and internal core temperature, for thermal comfort, for lighting, for ventilation requirements, for different building purposes. So after conducting energy auditing and assessment, so what happens? So for example, the client will need to know what happens to his energy consumption if he is to implement any of the recommendation. So for example, as part of the energy auditing report, the energy efficiency rating is important because it will give an idea to the client. Okay, this is your current, this is the current energy efficiency performance of your facility. And if you are to implement this energy efficiency measures, there will be improvement in the energy efficiency rating. So hopefully it would be able to improve with one or more energy classes. Also, by reducing the energy consumption, we're indirectly reducing environmental CO2 impact as well. So the client will have an idea if you present this in a report to see, okay, this is the current situation. And if I am going to invest this amount, I would be able to get this potential savings, which will improve my impact when it comes to CO2 generation as well. So to proceed, as Muslims, we have a duty. We should be able to make reference to environmental sustainability from religious perspective. So it's clearly stated in different, be it in the Quran and Hadith, about saving. Allah doesn't like the wasteful. So this is just to remind us that we should always get back to the basics and try to, it also shows how important energy efficiency is. So this is to encourage us. And I will leave us with this quote from Jill Owen. The greenest unit of energy is the one that is saved, not the one that is used, irrespective of how cleanly it is generated. And this is true. So, no, irrespective of the sources of generating energy, if you are able to save certain quantity of energy, it's better than to use it, even if it is cleanly generated. So we try to be fast, considering the time of the day. Would attempt to respond to some of the questions because this is the end of this presentation. Thank you so much for listening, and the floor is open for questions. So any question? Okay, thank you also for your time. And Dr. Abdurrahman is asking if we have any contact. Yeah, we have a contact. The Center of Excellence in Energy Efficiency could be reached to, which should have okay. Yeah, we can be contacted through CEEE at KFUPM.edu.se. CEEE .edu. CEEE at KFUPM.edu.se. So I will just type it now. So any more question before we call it a day? Okay, Dr. Fawad Azim, you can unmute yourself and proceed.
Assalamu alaikum. Thank
Walaikum
you very much. Thank you very much for a very good and brief, quite comprehensive presentation. I am from ComSat University Energy Research Center working on energy audits. Recently, we have conducted industrial energy audits also. I just wanted to ask one question that is related to the benchmarking.
Mm.
You have also discussed in your presentation that is level 0 of energy audit, that how we can go for the benchmarking. Could you please elaborate that?
Okay, if we go back to this under levels of energy auditing. Yeah, so what's your question again?
I just wanted to ask about the benchmarking, level 0 benchmarking. So could you please explain this level 0 benchmarking? What is it?
Oh, okay. So in level 0, basically it's sometimes be conducted. For example, you just use your intuitive experience, walk into any facility or a building and try to identify some, so it's been referred to as a low-hanging fruits. So if you are able to see based on sometimes physical investigation, okay, you'd be able to see, okay, yeah, we could save this from here. This needs further investigation. There's an issue here. There's an issue there. So sometimes it's like it could be through a walkthrough visit, which will just require some identification of low-hanging fruit, and if necessary, some very little unlimited analysis, or maybe just some maybe you just take some data for just few hours and take maybe few measurements here and there, and you'll be able to make some quick judgments. I don't know if this helps.
Thank you so much, sir. Jazakallah.
Thank you, Dr. Fahad. Dr. Fahad. Also, you may feel free to share some maybe some knowledge, some experience in this regard. Maybe a lot of us will benefit from you.
Well, thank you. We recently conducted an energy audit of a textile firm, and in that textile firm, we came to know and we concluded that whenever you are going for an energy audit of a textile firm, the lighting audit is very much important, and it almost shares the 30% of the power, the energy that is being consumed in that facility. So as you have also mentioned that energy audit of lighting is very much important, especially in the textile sector. The importance, the significance of lighting is increased or enhanced. So I think that whenever we are going for the energy audit, especially for the textile sector or the sectors like where the lighting is required, we should go for more detailed analysis of the lighting. And obviously, the power quality, as you also discussed, is very much important as far as the electrical audit is concerned.
Thank you very much. So this is really huge for lighting energy, lighting load to be of about
Exactly. It's about 30%. So we were also very much surprised to see that, but that was a learned lesson that it could be more than even 30% of any facility.
Yeah. So most likely they were using some obsolete lighting technology. Maybe there was when it comes to the maybe design issue, maybe old technology, for example, maybe metal halide lamps and a few things like this, and some other reasons could be as well.
Actually, they were using a lot of lighting. Although they were using LED lights, but the application where the LED lights were needed were much more than that of the need of that particular application. For example, they were using the 45 watts LED bulb, and we just did an experiment, and we saw that even a 20-watt bulb was quite okay with that application. So in that sense, they were using a huge energy. They were using 45-watt bulb, and almost in one hall they were using about 200 to 300 bulbs of 45 watts.
Yeah,
so if we, yeah, that was a huge. And when we checked from the lux meter, the 20 watts even was serving the purpose. So they were using about 50% more of the energy. So that was what we saw there. And you are absolutely right that there were some problems that we identified, not with the technology, but with the utilization.
I see. Thank you very much for your contribution, Doctor.
Thank you, sir. Thank you.
I think there is a question from Dr. Abdurrahman. Abdurrahman Dr. Abdurrahman, can you? I will just allow you to communicate so I can get exactly your question. Dr. Abdurrahman, can you unmute yourself and share your question? It's not.
Hello.
Yes.
Yes, please. Thank you for your presentation. It was very informative for me. Actually, I was working in energy efficiency a long time back when it started in 2006 with Japanese people. This is when it started, the energy efficiency in Saudi Arabia. My question to you, some of the issues that we face here, and if we were going to do some auditing, is the contract and reports. Okay, as you can see, it's all some of things that cannot be applicable to Saudi Arabia. So is it possible if we can find some of your initiatives regarding this contracts and reports that we already applied in our country?
Okay, so if I get thank you very much, Doctor. So if I get your question, you are talking about the contract, the agreement right at the beginning between the client and the energy service company, for example, to be able to agree on specific needs or aspect that needs to be covered during the energy auditing.
Yeah, you're right.
Okay, I think this could be subjective. One thing is that, okay, you could agree that, okay, this energy auditing is going to be level 2, but of course we all know that level 2 energy auditing will differ from facility to facility depending on how complex the facilities are, the nature of processes, the size, and there's so many factors, the location, many things come into play. So I think that what one could do is, okay, first identify which level of energy auditing with the client. If the client, for example, is opting for level 2 energy auditing, so you could try to see, okay, based on the various stages or steps required in to be covered before level 2 energy auditing is said to be fulfilled. Okay, relate each of these steps to the specific facility in question and see how complex it would be to accomplish that. Then based on that, you would be able to tailor the requirements or the contract and agreement, because as I agree with you, as you mentioned, it could be a bit complex, and sometimes it comes with a bit of some issues. So I don't know whether this will help.
Oh yeah, thank you very much. I will contact you guys later on, through your energy efficiency center.
Thank you very much. So people are asking of the slides. Yeah, I think the KICS, the KFUPM Institute for Knowledge Transfer, they will take care of this, and they will contact you. You will get it hopefully, inshallah, accordingly. This is question by Mr. Nasir Abdullah. Al-Abdullah. So any further question? Mr. Sulaiman, can you unmute yourself and proceed?
Assalamu alaikum. Like I wanted this small clip, to be clear. Benchmarking is basically the comparing, I mean, correct me if I'm wrong or right. It's just comparing the building to another building, which is in very good condition from energy perspective. Am I right?
Sorry, can you come again?
So now we have two buildings. So if we're going to do the benchmarking for a new building, we have to compare it with another building which has better energy consumption. Am I right?
Yes, benchmarking in general, this is what it means. But one thing I may want to add here is, okay, for example, sometimes how would you know, this is just like a question, how would you know that, okay, this building is having more energy performance than the building in question? Is it because you have conducted energy auditing, or is it because just it is, for example, relatively new compared to the other building in question?
Exactly. So now we have, for example, we cannot compare a building in, for example, in Dammam, where there is a high humidity, to a building in California where the weather is more, I mean, in better weather condition than Saudi Arabia. So if we are comparing, at least we have to compare to a building in the same environment and on the same age, I would say. Am I right?
Okay, the same environment, the same age, the same function, right?
Yes.
Thank you for this correction. Actually, I think what I explained in benchmarking is more of part of level 1 energy auditing instead of benchmarking. So thank you for this clarification.
Yeah,
Mr.
so just I want to clarify to myself too, and the others. And my second question, if we are comparing to another building, is there any standards? I mean, is there any standard, say a hospital will consume this much of power? I've heard there is a standard in US or somewhere in Europe, but it is far away from Middle East. So do we have in Saudi Arabia with, I mean, codes or standards we can our audit can or could rely on this data?
Yeah. Okay. I think when it comes to these codes and standards for Saudi Arabia, the Saudi Energy Efficiency Center is working on this, and also this center, the Energy Efficiency Center, is assisting the Saudi Energy Efficiency Center in one way or the other to try to come up with these things. But already in Saudi Arabia, for lighting, we have the Saudi Lighting Code, which is it is a draft, but it has been utilized so far. This is for lighting. This I'm sure.
But from HVAC point, from HVAC and pumping system or plumbing system is not finalized yet.
I think this is
right.
Based on my understanding, I think it's not finalized. If it is, I think it's yet to be available. So with time, because there's as we have seen, there's a lot of initiative taking place. There is a lot of interest and investment towards energy efficiency. So hopefully this comes into light as soon as possible. So I mean, not long, without taking much time.
My third question. Sorry to take so long.
No, you're very welcome.
Now, thank you. Now I'm by the way, I'm a mechanical engineer from Saudi Tabrid company who's building district cooling plant, and we are building something called energy storage tank, which is basically we are storing cold water. Now in Saudi Arabia, like the bill price or the kilowatt price is constant. It's not changing because I mean at night or more in the day or at night it's the same price. not like USA or another European country.
Where
So-
you have different prices for peak period of the day.
Exactly. So in Saudi Arabia, I think this method or methodology is not, how can I say it? It will not be cost effective like USA. But if we use it with, or if the rules somehow developed and shifted to where we will have different prices, that will work in Saudi Arabia, right?
Exactly. This point is valid, but I think it will need time. Like Saudi Arabia is moving in stages, so that would.
Yeah, I completely agree with you. I completely agree with you. But from operation, or I mean, can I use it to save energy on a constant price? That's basically my question. I mean, using the thermal energy storage to save money in this condition, where the price of the kilowatt is constant.
Actually, I'm not sure. Like,
let me elaborate on that one for Sulaiman.
okay.
Yeah, if you allow me. Some of the Riyadh buildings, tall buildings, they're using what they are doing is they're freezing the water in the top of the building during the night because the electricity consumption is lower. So in the morning, they will release it through the air conditioning. This is how they do some cooling comforts during the day. This is how they done the energy efficiency in the air conditioning.
Even though that the price is constant for all day.
Yeah, we understand that, but you know what? The energy consumption during the daytime of the air conditioning is more than the energy consumption if you're using it at the night time. So this is why they do some freezing of the water, and then they release it in the morning during the daytime. So it will be a little bit of reducing the cost of energy of the electricity consumption.
Sorry, Doctor. Like if I can have your contact, I would be very happy to contact you and discuss with you about this. Because honestly, like I still have, misunderstanding. How do they make money? I mean, with numbers. Like if you can help me, I will appreciate it.
Yeah. So, Dr. Sulaiman, can you also give your contact? CEEE can also officially try to get in touch with you to discuss further.
Yeah, sure.
In addition to Dr. Abdurrahman.
Thank you, Habibi. Thank you. That's all for me.
Okay. Can we get your email address also?
Yes, I will send it right now.
Okay. So I think there were a lot of sorry, there are a lot of questions related to the presentation. So as I mentioned earlier, Kix is going to take care of this, inshallah. Okay, gentlemen, thank you very much. I think we'll call it a day from here, and hopefully we'll see you tomorrow in continuation of this energy efficiency workshop. Thank you so much for your time. It's highly appreciated.